I didn't have precalc last year.
So?
So you teach your calculus class.
He doesn't have to.
They don't have to graph tangent.
We're his only hope.
I'm
It's
going
not
to
right.
fail you and telling you that right now.
It's not Riley?
No.
Why?
Wait, is it Henry?
Could be Henry.
We got this.
Did I push play? Oh, I did.
Yes,
Or
so
record,
they all
I
just
should
heard
say.
that debate on who it is.
Who are you? This is gonna be random, some random person that. Fun.
I told the
From
seniors
another
that they
school.
should watch the videos and like comment like really generic stuff like good math, nice handwriting, that kind of thing. None of them have done it, so
First, they should not make retards.
yeah.
They act like retards on an everyday basis, don't you know?
Yeah, I know. They were over Cliff, like all the way twice or Cliff American at that lake yesterday.
I know, I like that, like, that's fun.
Good old
And I was just
tangent.
thinking they're gonna get ticks and snakes. And I'm just gonna stay home.
They're gonna get ticks and snakes and.
Yeah, and I can.
Tangent's a little crazy.
Not snakes, a little.
Tangent can die.
It just looks weird.
Tangent doesn't exist. It's just happening.
Basically, the way to graph tangents is to find, there's vertical asymptotes in tangents, graphs,
Yes.
because there are places where tangent doesn't exist. If you recall, the tangent is equal to sine divided by cosine, right?
Mm-hmm.
So where will tangent not exist?
0, 0.
No.
When cosine is zero.
When cosine is equal to 0.
Oh. So it can't
Does
cross the x-axis?
it, hold on, exist when
Wait, what's confusing?
cosine of theta equals 0. When does cosine of theta equal 0?
When the back number is
Like
zero?
what is the angle
Pi.
that gives you cosine
Oh,
equal
wait.
to 0?
Pi over 2
Yes, x is 0 at pi over 2
and 3
and
pi over.
3 pi over 2. Or it's basically every pi over 2. So it's pi over 2 and negative pi over 2. And every iteration of pi over 2. After that. Iteration. Then the next one would be at 3 pi over 2. We're just going to graph a couple. That's good enough.
Does it like continue like a pattern?
So these, if I plug in pi over 2 tangent, I get no solution. So there will be, yeah, it repeats itself. So really, if you graph one of them, they're all the same. It's just like a tiling. Like it's just like boom, 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 boom. Like there's just a whole bunch of the same thing. Because it repeats, right? You just go around the
Yeah.
circle. You just get your
So
finger.
like it, what would it be? So like 2 pi over 4, like as it goes on, right?
Huh?
So like it repeats itself past those 2, right?
It repeats it.
Aubrey.
You just need to graph one of them basically, and you got them all.
Yeah, but like it keeps going, right? Oh,
Yeah, it's just like copy, paste, copy, paste, copy, paste. All the teaching in the 21st century. So
Your name
plug
is
it,
George now.
plug it in numbers. If we plug in 0, the tangent of 0 is sine of 0 divided by the cosine of 0. What's the sine of 0?
wait.
0.
I didn't even look.
The sine of 0, the y coordinate of this point is 0. The x coordinate of this point is 1. 0 divided by it's 0.
So that's how you
Yeah, we're going to plug in 3 points now.
Why?
That's it. Right now we're going to plug in pi over 4. Well, the sine of pi over 4 divided by the cosine of pi over 4.
Pi over 4.
Do you know the sine of pi over 4 at the top of your head?
No.
Square root of 2 over 2.
Yes, that is correct.
You know the cosine of pi over 4, also the square root of 2 over 2.
So that is 1.
That is 1. So at pi over 4, we're at 1. And guess what? If we're at negative pi over 4,
It's gonna be 1.
nope.
No? Wait, where are we?
Negative pi over 4 would be this way.
That's the
Cosine
sine.
is still pi over 2, or root 2 over 2, but the sine is negative root 2 over 2, which results in negative 1.
Yes. Yes, indeed.
There it is,
Jack
folks.
Levy. He's at WSU orientation.
Okay, he's still Jack Levy.
He's busy.
He's still Jack Levy.
He's busy.
He's still Jack Levy.
There's the tangent graph. A whole bunch of those things.
So it's like one of those x cubed things,
Almost like that.
This one's
Not quite.
weird.
but it repeats.
So these
Yeah.
are pretty much funny looking things that just keep going.
Yeah, and then it just keeps going and going. Like there's infinitely many of those little things with vertical asymptotes between them.
It stays the same though, right?
Right. Yeah, so when you graph it on a graphing calculator, it's like, wow, that looks so weird.
Crazy.
Yeah, it's just whoop, 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 whoop. That's it.
That's really irritating.
And if you zoom out, there's just more of them. So, I mean, we can do lots of stuff with this, but I don't really want to. Let's do one more. Negative 3 times the tangent of 2x. Step 1. What do you suppose we want to find first?
The
That's great.
asymptotes.
The asymptotes, yep.
No. It's too hard.
And where are the asymptotes going to happen?
At the 3.
It's whenever this thing inside of here equals pi over 2, or 3 pi over 2, or negative pi over 2, just like that.
Okay, so pi over 2 divided by that?
So we'll go when does 2x equal pi over 2, and when does 2x equal negative pi over 2, or you could do 3 pi over 2, whatever.
Can you just
We're
divide
going to
this
go on
by
either
two?
side of this first. Divide both sides by 2, so it's when x is pi over 4, and when x is negative pi over
Oh, that's this right now. No, I don't.
4. So those are where your vertical asymptotes are. So we'll go like this. We'll go pi over 2, there's pi over 4, so that's a vertical asymptote.
Oh.
There's negative pi over 2, so there's
Bless you.
vertical asymptote. Let's see. My sneeze? Okay. Now,
No.
plug in. That's it. It's so easy.
Really?
Plug in 0, and you're just like,
Well then, it's even smaller though, you have to plug in like 1/8, right? Or
yeah, you gotta plug in some crazy numbers.
pi
So it's
over
the
8.
sine over the cosine. If I plug in, this is pi over 4. Oh, I'm plugging in 0 right now. So
It's sine divided by cosine?
yeah. Sine is 0, 0, cosine is 0 is 1, so it's just 0.
So it's 1 over root 3.
It's 0. Or you can just root.
No, I was doing pi over 8 right now.
Oh, you're doing pi over 8?
Yeah. Oh wait, but that's pi over 6. It's not on here.
This is pi over 4. This is pi over 8.
No, but it's not on the
Okay,
circle.
but watch. When you plug in pi over 8, you're going to multiply by 2. Thus resulting in
Pi over 4.
pi over 4. So we're going to do the sine of pi over 4 over the cosine of pi over 4. So which is the root 2 over 2 divided by root 2 over 2,
Which is 1.
which is 1 times negative 3,
So negative 3.
negative 3.
Oh. And the other way would be.
And you know what? They're always symmetric.
So it's just
So the other
opposite.
way is going to be positive 3. And this one goes. And this one's going to go the same exact way. See? Pretty easy, huh?
So they always look retarded like that?
Alright.
Yes.
I can do that.
Like they look like they don't know how to be a straight line. Because they don't.
We don't.
My brain is very fascinated right now.
Makes sense.
Good. All right, let's do some. I don't want to do cotangent. It's just cosine. It's the same thing. It's just cosine over sine. So they look pretty much the same, almost.
So it's just the reverse?
But it's just cosine over sine. I guess the only difference is your asymptotes. So we should do 1. Let's just do 2 times the cotangent of x over 3. To find the asymptotes is a little different. It's not pi over 2 and negative pi over 2 anymore. When will cotangent not exist?
When sine is 0.
When sine, yeah, because remember this is flipped. This is cosine over sine. So it's when sine is 0.
So pi,
When is sine 0?
pi and 0, and 2 pi?
Pi and 2 pi, or 0 and pi, or yeah, let's just go 0 and pi. So it's when the stuff inside the parentheses equals 0, and when the stuff inside the parentheses equals pi, we'll have vertical asymptotes.
Oh, okay.
Right? So that'll happen at x equals 0 and at x equals 3 pi. I'm just going to graph one period of this only. 3 pi. Could just scaled it smaller and drawn 2, but because I think in your homework it tells you to draw 2 full periods.
Doesn't mean.
We're just drawing 1 right now. And then, again, well, from there, plug in numbers, but plug it in as cosine over sine times 2. Right? You know what I'm saying? I need to continue.
Yes.
Yes? Okay.
No.
Okay. What do we want to plug in?
Pi?
Pi? Sure. We can plug in pi. If we plug in pi, we get pi over 3. You want to plug in pi still?
What's the middle thing?
The middle of 3 pi and 0.
3 pi over
3 pi over 2. I plug in 3 pi over 2.
2. Alright.
If I plug in 3 pi over 2 for x, 3 pi divided by 2 divided by 3 is 3 pi over 6.
What? No. 3 pi over 2, and then you flip the 3. Oh, okay, yeah. So then it's 1/2 pi.
It's pi over 2.
Or that.
So I'm going to do pi over 2, pi over 2. The cosine of pi over 2 is 0. And 0 divided by anything times 2 is
0.
0. Now what do you want to plug in? Amy, you lost? Yes?
What's the middle point between 0?
I picked the middle of this and this.
Oh, yeah. What is it?
In the middle of that.
That's what I've been trying to figure out.
The middle of 0 and 3 pi over 2 should be easy.
3 pi over 8?
No. What's half of 3 pi over 2?
That's a solid question. Why am I struggling with that?
Half
To see it.
of 3 pi over 2.
Oh,
3 pi over 4. So let's plug
Didn't I
in
say that?
3 pi over 4.
I'm pretty sure I said that, and then you said no.
There's 3 pi over 4 right here. So if we plug in 3 pi over 4 for x, 3 pi over 4 divided by 3, which is, I'm going too hard
3 pi
on
over
fractions.
Hold on.
3 pi over 12,
Oh, hey,
which is
I
pi
was
over
close.
4.
I added.
So we're plugging in pi over 4 of these. And the cosine of pi over 4 is root 2 over 2, and the sine of pi over 4 is root 2 over 2. So that's just 1 times 2. It's 2. And so guess what? If I go in the middle over here, guess what I'm going to get?
This
Just
opposite.
Negative 2. And so there you'll have it.
Sweet.
Alright, we gotta do one more. We gotta do a cosecant or a secant.
Let's do
The
secant.
idea is the same. Yeah, Tuesday.
You just put it over 1, don't you? Or under 1, I mean.
Want to graph secant or cosecant? You're only getting one.
Secant.
Secant. Let's go with, let's keep it simple, the secant of 2x. Tell me what you know about secant.
That it's the opposite of cosine.
It's 1 over cosine.
1.
So the way you do these is you actually graph the cosine first, and then you just graph the reciprocal on top of it. So really what we're doing, this is on a quiz it's great because I don't have to give you ones with cosine and sine because I just give you secant, cosecant, and if you can't do the cosine and sine, then you can't do anything.
So if you can't do one part, you get it all wrong. That's even better.
Pretty much.
Man.
So really we're going to graph y equals the cosine of 2x first, real quick. We only have 3 minutes. By the way, if you're a senior or you have graduated and you're watching this,
Oh, I was like, there's no one here.
you gotta tell me somehow that you're watching this, and I'll give you some extra credit. Maybe your grade will go up because I haven't done your grades yet. I haven't entered them. So anyway, cosine of 2x. Crap, we gotta hurry. Let's go.
That one details that.
Pi, 2 pi. What's the period? 2 pi divided by 2. The period is pi. Cosine of 0 is 1. So this sucker's going to start at 1. And it's going to get back to 1 by pi. So in the middle, it's going to be like, wait, it's going to drop through. It's going to be low. It's going to be negative 1. So basically you do all this, and you graph your cosine. Right, something like that. I just did that real quick. Hopefully you remember how to graph cosine from yesterday. There's good enough. Okay, so in pencil we have the cosine of 2x. So then all you do for the secant is you remember like the little, it's almost like the little big principle. Remember that? Because the secant is just a reciprocal of that. So it's 1 divided by all of these points. So guess what? We're going to have some horizontal or vertical asymptotes in. Where would the vertical asymptotes be? It's wherever the x-intercepts. Because this is where y equals 0.
So
there's going to be vertical asymptotes at every x-intercept.
it's like that parabola stuff we were doing. Right?
It is. It's exactly like that.
Indeed.
And this isn't very symmetric. These should all be symmetric. And then within each vertical asymptote,
It flips.
it flips. Well, if you have 1,
No freaking
1
way
over
about
1
that,
is
right?
still just 1. And then this is positive and it gets really, really small. So this is going to be positive and get really, really big. And they're all going to do that. You basically just go off the tops of the hills and the valleys and you make little parabolas. That's essentially what happens.
Sweet.
And if you look at page 421 in your book, it gives you like the drawings without the sine and the cosine there. But when you do them yourself, you draw the sine and the cosine, and then you put parabolas on top of the hills and the valleys.
Hey, on the test, are you gonna have us actually draw them out?
Yeah.
So we have to. What's an acceptable amount of repeats to draw? 3 or 2?
2 periods usually.
Okay.
There you go. There's for tomorrow. Because I won't be here tomorrow, so give you something to do.
Where did